G really gotta stop starting early. You know, it's fine.
Okay, we'll get started in a minute. Let me just get everything set. All right. So, okay, everything should be okay. You should be able to see the screen now. I have notebook attached. Basically, we're gonna finish this lesson up today. This is just the same absolute value equation, solving them, and so far, we've seen solving, just basic solving. We did questions yesterday that have two absolute values, and today we're gonna get to solve the ones with special solutions. Okay, so basically, what's different here is you notice that in every question we've done so far, I've always been very careful about checking the values that come out, and that's important for a reason because in a minute we're going to see solute questions where you get an answer, but the answer is not valid. So we have to be super careful about checking the values that we get. So let me go to the proper page. And here's the proper page. Oh, I left one out yesterday, didn't I? I didn't solve this one. So, all right, if there's time, we'll come back and solve it. There should be. Okay. So I want to just make sure I get these done because these are really important. Um, Identifying special solutions. When you solve an absolute value equation, it is possible for a solution to be extraneous. Okay. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. So what happens is you're going to sometimes solve and you'll see the answer you get when you substitute it back in. It doesn't work. And we call that an extraneous solution. Okay. And I believe we're going to see that in the first example here. Now, just something to bear in mind. It's possible that they both work, which all the examples so far, both answers have worked. It's possible that only one works, but it's also possible that none of them work, right? And we'll talk about that in a second too. So just to refresh your memory, the way you solve absolute value equations when there's only one absolute value symbol is, and this we did a couple of days back, whenever we have ax plus b equals c, the way in which you get rid of the absolute value symbol is by making two different statements, right? You would say ax plus b equals c. There's your original. I didn't change anything. And then the alternative one is ax plus b equals negative c. And we talked about why that is yesterday. You need two statements when you're working with absolute value because there are two potential answers. So that's why that has to happen like that. Okay. Anyway, in this question, we have 2x plus 12 equals 4x, only one absolute value, and we're gonna solve this and then check out solutions. And then after I'm done doing it algebraically, of course, I'll show it to you graphically because I want you to see what's happening. So I'm happy in this question because 2x plus 12 is by itself, the absolute values alone. So I can split this into two equations. I can say 2x plus 12 equals 4x, and I can also say 2x plus 12 equals negative 4x. Okay? Because I can make two statements because I that's the way in which you get rid of absolute value. I have to make these two statements. Okay, so all I did, I kept the original one, and then the alternative one, I changed the sign on the other side. Negate C. I negated C. 4x is in the C position, so it's negative 4x. And now from here, I'm just going to solve each of these individually and let's see what happens. So let me solve this one first. I'm going to subtract 2x. I don't have a choice because I have to get the x's together. So, and they're on opposite sides of the equal sign. So I'm going to subtract 2x. This is the inverse operation, just doing the inverse operation. And then these cancel out. And then my 12 comes down. And 4x minus 2x is 2x. Now I'm almost done with this side. I have 2 times something equals 12. Well, to undo multiplication, I just divide by 2, and that makes these 2's cancel out. And if I divide by 2 on the right, of course, I do it on the left. And when I do 12 over 2, I get 6. So 6 equals x. In other words, x equals 6, but I don't know that 6 is a valid solution. So I'm not going to box it up yet because it may or may not work. All right. I got to be really careful. So let me just leave this like this for now. I'm going to come up and I'm going to solve the alternative equation on the right hand side here. And I'm going to use the same tactics I did over here. I just got to get the x's together. So to undo the 2x, I'm just going to subtract 2x. Again, I have to get the x's together. So that's really this is probably the fastest way of doing it. When I do that, I bring the 12 down, and negative 4x and negative 2x is going to give me a negative 6x. And of course, I have to try to get x all by itself. So to undo multiplication, I'm going to divide by negative 6 now. And when I divide by negative 6, these cancel. And if I divide by negative 6 on the right, of course, I have to do it on the left. And when you divide a positive by a negative, you get a negative, and 12 divided by 6 is 2. So what I can say now is it looks like x equals negative 2. Okay, before I go any further, let me just stop and take questions. Are there any questions so far? Anything at all? Anybody confused on anything that I've done so far? Setting it up and making two equations and solving the two equations? Anything? No? Okay. So I have to assume that we're good. So if we're good, this is where I need you to be careful. You're taking an exam, the state exam, let's say, and you might see something like this. Choice A might say negative 2. Choice B might say 6. Choice C might say something like negative 2 comma 6. And choice D might say this. That means the empty set, that just means that there's no solution. Okay. Now, if you are not careful, you may end up circling, oh, look, I have negative 2 and 6. I see that right here. So the answer must be C. Well, I don't want to circle that yet because I don't know that. There's a chance that these numbers might not work. So if you don't check, all right, you're definitely going to circle C. And if you do that, you're actually going to get the problem wrong. And you're going to see why it's wrong in a minute. The answer, both of these do not work. Okay, so you're going to see why. I'm going to check this. I'm going to check 6 first. I don't know. The order which you check is irrelevant. I found it first, so I'll check it first. So I'm going to check 6 by substituting it back into this x here and this x here. Okay, it's going to go into both x's. So really, I have 2 parentheses 6 plus 12 equals 4 times 6. Because again, I'm replacing all my x's with 6's. Okay, if we work this out, 2 times 6 is going to give us 12. And on the right side, 6 times 4 is 24. Okay, 12 plus 12 is 24. And then the absolute value of 24 is 24. Because the absolute value of a positive number is that same positive number. And there's nothing to do on the right. It's just 24. I'm carrying it down. There's no work to do. So clearly, using 6 makes the left and right side equal. So I know for sure now that 6 is indeed a solution. It makes the statement truthful. Okay. It makes the original statement work out. So that means that 6 is definitely a solution, and I can put a box around it because I know it works. Now, I have to do the same thing for negative 2, and I haven't shown that negative 2 works as of yet, and I have to go back and do that. So let me take negative 2 and substitute it back into the original like I did with 6 and do the same thing. So this says the absolute value of 2, I'm replacing my x with negative 2 plus 12, close the absolute value symbol, equals 4 times negative 2. So let's see what happens here. 2 times -2, that's gonna give me -4, and then -4 plus 12, or 12 minus 4 is 8, and then the absolute value of 8 is 8. Okay, so that wasn't too hard. On the right side, I'm just multiplying 4 times -2, which is -8. So I got -8 there. And clearly 8 and -8 are not the same. They're not the same thing. 8 is not the same as -8, which means that when you substitute -2 into x, it does not make the statement work. Okay, this is an extraneous solution, and we can abbreviate by saying ext. In other words, -2 is not a solution. It doesn't work. So the only thing that works, the only answer is going to be 6. So if you circle choice C, you're incorrect. Okay, it's choice B that's the answer, because 6 and only 6 is a valid answer. -2 is not valid. Please don't think that that always the negatives are not going to work, and that's not true. The only way to know is by actually doing the work and performing the check. So this is all the algebra. This is to do it algebraically to see what's happening. This is a full algebraic proof. Everything's shown. It would be a full credit response. It was in the back of the booklet, right? Because I don't know where you're going to get this question. It might be multiple choice, or it might be in the back. So I have to, I have to show you all the ways of solving it. Plus, I want you to have an understanding of how to solve this problem both algebraically and graphically. So we're not done with it, because I'm going to actually jump into Desmos now, and I'm going to do a graphical solution to 2x plus 12 absolute value equals 4x. So let's take a look. Before I jump though to that, are there any questions about anything that occurred algebraically? Anything at all? Anything? Okay. So if there aren't any questions, I'm going to jump into Desmos then, and we'll take a look. Okay. So let's do that now. Let's go into Desmos. Um, okay. So let me just erase this stuff. Okay. So the question is 2x plus 12 absolute and 4x. Oh, before I do anything, can I just need verification? Is Desmos visible? I just need somebody to tell me if it's visible. You could say it or type it in the chat.
Yeah, it is.
Thank you, thank you. Okay, so since it's visible, great. Because sometimes for some reason it doesn't pop up, so I just want to make sure. So, so I got 2x plus 12 as in the absolute value symbol. So 2x plus 12, that's in the absolute value symbol. And the other side of the equation was 4x. So there's 4x. Now, you look at it like, oh, I don't see anything crossing. Well, you have to zoom out, okay? Because, uh, yeah, it's too zoomed in. So just zoom out, okay? And you can see that they're only going to intersect once, right? The purple line and the green line, they're pulling away from each other, so they're not going to touch again. So the only intersection point is 6. Okay. I don't care about 24, because 24 is a y value. I only care about x value. So I'm trying to solve for x. So the only number that's relevant here is 6. So 6 is the answer. Okay. It's the only answer. We also found, and when we did our work, we found -2, but -2 is not an answer. If you look at -2, okay, -2, and it's like right here. I'm sorry, I can't get it perfect. -2 is right here. They do not intersect at -2. The green graph, the absolute value is up here, and the purple graph is like down here at -2. They definitely don't touch at -2. So -2 is meaningless. It's not a solution. It's not a value. Okay, it's not a solution. The only solution is 6. Okay, so it's 6 and only 6, and that's why B is the answer. Okay, so let me go back into Notebook. Okay, it's loading back up. Okay, it's loaded back up finally. So we can see that that B is the answer. Only B, only 6 works. Okay. This is a question where we had one absolute value, and I believe the next question, um, this one here, is like the questions we did yesterday, where there are two absolute values, and that doesn't really change anything in terms of setting problems up, it's still the same strategy where you leave one alone and the other one you negate the other side. It's still the same strategy for two. I'm going to put the strategy over here in case you forgot because this was yesterday. So whenever you have ax plus b equals cx plus d, right, two absolute values, you end up with 1 ax plus b equals cx plus d. That's the original. And then you also end up with ax plus b equals negative, negate the entire side, cx plus d. Okay, this is in your notes from yesterday. So this is just the stuff we did yesterday. Okay, I'm just going to try to slide it over a little bit. Okay, so it's not my way. All right, so that, okay, that's from yesterday. That's the strategy we use to undo the absolute value. At this point, you have to be comfortable with when you undo absolute value, it results in two equations. Okay, not one, two. So the first equation that this is going to result in is going to be x plus 5 equals x plus 11. That's easy. There's nothing to do. I just take away the symbols, right? That's just this. And then the other one's going to be x plus 5. Well, I have to negate the other side. So negative parentheses x plus 11. And we'll take care of that work momentarily. Before we worry about this, let's just solve this side first, and then we'll come back and take care of the alternative equation. Personally, I like to do one equation at a time. I think that that's probably going to be the easiest for the majority of people. So for this one, I have to solve by getting the x's together as usual. So I can subtract x. If I subtract x here, I got to do it on the other side as well. There are no like terms on the same side. I think somebody asked me that question yesterday. The like terms are on the opposite side, so I have to subtract x from each. Something interesting happens. These cancel, but so do these. And then I'm left with 5 on the left side and 11 on the right side, which these aren't the same thing, and I can't do anything because the x is gone. So I'm not going to be able to get an answer out of the original equation. I'm not going to be able to get anything. So because it ends like this, I'm just going to stop. There's nothing more for me to do on the left side. Okay, so this is done. I can't do anything. I can't solve for x. It's not possible. However, it doesn't mean I can't solve for x here. So I'm going to have to work the other side out now and see if I could solve on this side. And I have to use my algebra skills to do this. I know I have x plus 5. And you have to know then that this negative distributes to everything inside the parentheses. And the x then becomes negative x. And the 11 becomes negative 11. Okay, because the negative has to be distributed to both sides, to both things inside the parentheses. From here, you have some choices. You can move anything that you want. I like to do the x's first, so I'll actually do plus x to this side and do plus x here. You don't have to do it that way. So these cancel out. 1x plus 1x is going to give me 2x. Bring the plus 5 down. And then bring the negative 11 down. Since I did it this way, now I don't really have a choice anymore. I have to get the 2x by itself. So I'll subtract 5 from each side of the equation to get 2x by itself. And that allows these to cancel. And then I can say 2x equals negative 16. Okay. And then to get x all by itself, the inverse operation of multiplication, of course, is division. So I'm going to divide by 2 on each side of the equation to get x all by itself. And when I do that, these 2's cancel out. And I have x equals, well, I know a negative divided by a positive is a negative. And 16 divided by 2 is going to be 8. So I have negative 8. Now let's be careful because we don't know whether or not negative 8 is going to make this equation true or not. The only way to know if it makes the equation true is to actually do a check on negative 8 to see if it works, okay? So I don't know if it works or not. I have to put negative 8 back into the original, the one that came on the test paper. So in this case, negative 8's going in here. plus 5. So negative 8 goes in there, plus 5. And then negative 8 plus 11. Okay, well, let's see if it works out. Negative 8 plus 5, or 5 minus 8, well, that's negative 3. But then you have the absolute value of negative 3, and we know the absolute value converts everything to positives. So this side becomes 3. That's the left. On the right, we have negative 8 plus 11, which is really 11 minus 8, which is positive 3. And we know the absolute value of positive 3 is positive 3. So that means that negative 8 does make the statement truthful, and that negative 8 is a solution. Negative 8 makes the statement true. It's a solution. So that's the algebraic way of solving this and then checking it to ensure the value is correct. Are there any questions on the algebraic way of solving this? Because if not, I'm just going to jump into Desmos and illustrate this question in the calculator so we get a visual solution. Any questions at all about doing it algebraically? Anything? Okay, so if there aren't any questions about solving it algebraically, um, let's put this into the computer and take a look at it and see what's going on, okay? So let me do that now. Let me go to Desmos. Okay, so, okay, I'm just clearing this stuff out of Desmos. So at this point, Desmos should be visible to everybody. And I'm going to put the two equations in. And the equations are x plus 5, absolute. So absolute of x plus 5. I believe the other one was the absolute of x plus 11. X plus 11. So those are my two absolute value functions. I'm just going to zoom out a little bit. Okay. You can clearly see that the red graph, x plus 11, the one in red, and the black one, x plus 5, based on what I see, they're only going to intersect once because these two lines here are parallel, then they're never going to cross. And this line and this line here are parallel, they're never going to cross either. So the only intersection we're going to get is here. This is it. So the only point of intersection, as we have in our notes, is negative 8. We only care about x, we don't care about y. So negative 8 is all we care about. So negative 8 is the solution point. Negative 8 and only negative 8. And now we have verification. We have visual verification that's the solution. So negative 8 is the answer, which we have in our notes from doing it algebraically. So everything lines up. Okay, let me go back into Notebook. Okay, so let's get back in there. Okay, so now that we've done these two questions, okay, I'm going to leave you with two questions to do now. I'm going to give you like 5 minutes or so to work out two questions similar to the examples that I just did. I believe the ones that you have in your practice problems are look like this, though. There's only one absolute value. So let me take a look here. Here's one of them. I'm going to bring the other one up. 3x minus 2 equals x. So I'll put 11 next to it. So 11 says 3x minus 2. So 3x minus 2 equals x. Okay. So I'm going to give you like 5 minutes. You're going to solve each of these. You can use Desmos, get the answers. That's fine. But I want you to be able to work it algebraically too, because you don't know where this question is going to land on an exam. It could be in the back, and then you have to show the work. So let me give you 5 minutes, which should be enough time, I hope. Yeah. So take 5 minutes, answer these questions. I'll listen in if you have any questions for me, and then we can take a look at that. All right. So just do these now, and like I said, I'll give you 5 minutes, and then we'll go over them. But I want you to practice them before we go over them first. Okay. During that time, I'm just going to take the attendance, and I'm listening if you have questions. three more minutes. Okay, so that's the time. So let's take a look and see what we have for this first one. Anybody tell me how to start this? I don't want to take it away from people. I want people to get a chance to do it. Yes.
You made the two equations.
Yes. So what did you write for the two equations?
Okay, x plus 6 equals 2x,
X plus 6 equals 2x. Good.
and x plus 6 equals negative 2x.
Good. Okay, that's correct so far because you have to have two statements. One is the original, x plus 6 is 2x, and the other one you change the sign on the other side, negative 2x. This is correct. Did you solve this?
Yeah.
What would you do?
I subtract x on both sides.
That's what I did too. So subtract x on both sides, and that's going to make these cancel out. And now I have 6 equals x, right?
Yeah.
Okay, so x equals 6. Well, I'm not sure if it works yet, but we'll handle that in a minute. Okay, how about this side?
I did the same thing. I subtract x on both sides.
Sounds good to me. Subtract x from both sides. That's going to allow these to cancel out. And then we're going to get 6 equals, what is that, negative 3x?
3x, yeah.
And then what happened?
You divide negative 3 on both sides.
Looks good.
You get negative 2.
Yes, 6 divided by negative 3 is negative 2. Now, everything looks perfect. I agree with everything so far. The only concern I have is, are both of these answers valid?
No, because I checked it out algebraically and in Desmos. Only the six works.
Only the 6 works. Okay. Nice job. I'm going to show the check. You did it correctly. And you should definitely check it in Desmos. So what I think she did, everything here is perfect. This is full credit. Her response is full credit. What you do to check it is pretty simple. You just drop the values back in. So I'll show that. Again, everything is complete. She gives you a full view of what's happening here, and she has the answer correct, obviously. So if you put 6 in there, you're going to do 6 plus 6 absolute equals 2 times 6. Okay, and what we're doing is dropping the 6 into both x positions to make sure it works. When she does that, she's going to have 12, right? Because 6 plus 6 is 12, and the absolute value is 12. And here, you multiply those, and you got 2 times 6 is 12. So this is correct. So we can see that 6 does make the statement true. So I agree with her. Okay, it's right. And she's saying that -2 doesn't work. Okay, that this is extraneous. Let's deal with that claim. Let's see if she's right. I think she is. Let's make sure. So -2, we have to plug back in. So we're going to check -2. We're going to put -2 into the x positions, leaving me -2 plus 6 equals 2 times -2. So anybody confused about the checks are just where you put the value into the x position, okay? Both positions. And let's see what happens here. 6 minus 2 is 4. And then the absolute value of 4 is 4. Great. And here 2 times -2 is -4. And therein lies the problem. +4 and -4 are not the same. So when you put -2 into the equation, it does not make the left side and right side balance, that you get different answers. So that means that -2 is not a solution and only 6 is a solution. And I like that she said she also checked it in Desmos, which was smart because doing it visually is actually a lot easier. So we're going to take x plus 6 absolute and 2x, and we're going to substitute that into Desmos and then see and make sure that we only get 6 as an answer. So let me do that now. Let's do that now. So I'm just going to clear out the stuff we had in Desmos from earlier, clear this stuff out. Okay, and now we're checking x plus 6 and 2x. So the absolute value of x plus 6 and 2x. So here they are, and you're looking at, oh, I don't see them intersecting. Well, if you don't see them intersecting, zoom out. And you can tell that they're only going to intersect once because the blue line and this blue line and the green, they're pulling away from each other. So they're not going to touch again. The only place they touch is at, or intersect, is at 6. So 6 and only 6 is the solution. The other answer you had was -2. -2 is not a solution because -2, okay, -2, they're not touching. At -2, these two things are not touching each other. They don't intersect there. So -2 is not a solution. Only 6 is a solution because at 6, at x equals 6, the two graphs are intersecting each other. So that's the only solution. Okay. Uh, let's go back to notebook. And we got one more problem to do, and then we're pretty much set. Okay, so we have like 10 minutes, so we should be able to finish this up. So let me take somebody else to help me start this one off. So she did a good job. So if somebody wants to explain it the way that she did this one, it would definitely work. Chat. Can you please do homework number 1? Um, okay, if this, I'll do problems from it. Let me just knock this one out first, and then I'll do some problems from it. Think about the examples you want me to do. I can't do all of it, but if you want me to do 1 or 2 questions, I can. Okay, I need 3x minus 2 equals x. Can somebody knock this one down? Yes.
So the first equation will be 3x minus 2 equal x.
Okay, let me just change colors. So I'm going to have 3x minus 2 equals x. I agree with this. Yes.
Subtract x from each side,
Subtract x from each side.
and then you will get 2x minus 2 equal 0.
So this will give me 2x minus 2 equals 0. Okay, now what do you want me to do?
Add 2 to each side.
Okay, let me just clear this off. So now I have 2x equals 2.
Yeah, and then divide 2 by each side.
And x is 1, right?
Yeah.
Okay, we're not going to check it yet, but we don't know if 1 works yet. We'll check that in a minute, okay? But you still have to take care of the other equation, right? What was the other equation looking like?
So the other equation is 3x minus 2 equal negative x.
Nice. Okay, so he just copies everything and he changes the sign on the other side. This is exactly what you do. Okay, what'd you do next?
Add x to each side.
Okay,
So 4x minus 2 equals 0.
4x minus 2 equals, that's correct because these cancel out. This is 0 now.
Add positive 2 to each side.
I agree. This is good. You're going to separate these guys. So 4x now equals 2. Okay.
So x will be half or
Yes,
0.5.
correct. You divide by 4 on each side. So x could equal a half, or if you prefer decimals, x equals 0.5. I'm actually going to do 0.5 because it's easier for me to check with the decimal, but that's up to you. So let's see. We don't know that these work, right? They may or may not work. We have to check them. All right, you want to go through checking one?
Yep. So 3 times x equal 3 times 1 equal 3.
Okay, 3. Let me just get this written down. 3 times 1, and then it's minus 2, right?
Yep.
I'll let you take. Let me just write it down, and then I'll let you take me through it. So 3x x gets replaced with 1, and the other side also gets replaced with 1, right?
Yeah.
So it should look like this, right? Okay, go ahead. Carry on.
So 3 times 1 equal 3. Minus 2 equal 1.
And that's
1.
yeah,
Absolute 1 equal 1.
correct. So this is pretty easy. So we see that it works, right? X equals 1 is a solution because it makes the left side and right side equal. Nice. How about 0.5?
So 3 times 0.5. 3 times 0.5 minus 2 equal 0.5. So the other x.
Okay, perfect. So what is 3 times 0.5?
1.5
Yes. So this is the absolute value of 1.5
minus
minus
2
2.
equal 0.5.
Okay. $1.50 minus $2?
Yeah. So there will be minus 5. 0.5. Negative
Minus,
0.5
very good. And the absolute value of negative 0.5.
is 0.5.
So this one actually works out. Both of them work out, right? This makes the statement true as well. So
Yeah.
0.5 is also a solution. Nicely done. So he solved this one, he checks everything, and he sees that 1 and 0.5 are both valid solutions. They both work. What I'm going to do, just to be sure, I'm going to jump into decimals real quick and make sure that these two values we can see visually for this, okay? So it should be 3x minus 2 absolute equals x. So let's go into decimals really quick because that's always important. 3x, oops, the wrong thing. 3x minus 2. Okay, decimals is loading up. It should be visible now. So 3x minus 2, absolute. 3x minus 2. And the other equation was just x, I believe. Okay, let me just, okay. So let me zoom in a little bit. I can clearly see it does intersect twice. 0.5 is one solution, and 1 is the other. At 0.5 and 1, these two things are intersecting. those are the two x values, 0.5 and 1. There are two solutions here. So that's it for this one. And now somebody asked me about homework. Okay, so let me see. Number 7 from the home. Oh, okay. Number 7 from the homework. So let me see. Number 7. Okay, so just so we're clear, the homework starts on this page right here. So it's pages 10, 11, 12, and 13. 10, 11, 12, 13, and 14. So it's 10 questions. So number 7. Number 7 from the homework. So let's see. Because of time, I'm just going to try to bounce through this one. It says 6x plus 4 equals, okay, so my absolute values alone. So I can say 6x plus 4 equals 8x plus 10. That's the original. I didn't do anything. I just got rid of the absolute value. The alternative would be 6x plus 4 equals, I'll have to negate the entire side. So I'll do negative 8x plus 10. Okay. Then I have to solve each of these individually. So let me see. I can subtract 6x from the left side and the right side. That allows these to cancel. Bring the 4 down. This would become 2x. And the 10 comes down. Now I want to get the 2x by itself, so I can subtract 10 from each side. And 4 minus 10 would be negative 6. And the 2x comes down. To get x all by itself, I'd have to divide by 2. And x might be, I'm not going to check it because it's your homework, so I don't want to take all the fun away. Negative 3, it may or may not be negative 3. You'd have to check that on your own, okay? That's something for you to look at. For this one, it's 6x plus 4 equals negative 8x and then minus 10, because when you negate the right side, you have to negate everything on the right side. So please use parentheses so that you don't make a mistake. Once you get here, now you have options. I'm going to elect to move the negative 8x, but that's not the only way to do it. There's like 5 ways, more than that even. I'm just deciding to do it this way. That would be 14x plus 4 equals negative 10. And based on the way that I did it, now I have no choice. I'm going to have to subtract 4 from each side. And 14x is going to equal negative 14, because negative 10 and negative 4 is negative 14. If you divide 14 off of each side of the equation, to get x by itself, you'll see that x is equal to negative 1. And I don't know if it works. You're going to have to check that on your own. I hope I answered that question, okay? So the part that left for you is just to plug it in to see if it works. It makes a statement true or not. If anybody's having any other trouble with homework, please just email me. Sorry I went through that one quickly, but the time is running out, so I know it's 11:30. I don't want to keep you past. So I'm gonna stop the recording now. You can email me if there's any questions, but the only problems you're handing in for homework are the questions